So here we have that integral I mentioned. We were going to take a look at where we have a variable in ln. Now normally we like to let u be powers of x. That's generally how we like to set about that. But when you're involved with ln, this is actually kind of the exception here. You actually want to let the variable or the u actually be ln. Because otherwise, if you let dv be ln, then you have to deal with the integral. And so you're overcomplicating things now. Now you're introducing this new thing, which would be your new v if you did that. And things actually work out nice by letting ln be involved when you're doing power of x, for the simple fact that ln involves x to the minus 1 or 1 over x. So watch what happens here as we proceed, letting u be ln of x and dv I'm actually being the power of x. Because du will just become 1 over x. When we integrate, this will become 1/3 x cubed, which is 1 over x dx. So following the integration part by parts through, this would be uv, so 1/3 x cubed ln of x minus the integral of v du. Well, that's going to be 1/3 x cubed times 1 over x. Well, one of the x's cancel out, so we're actually just left with the integral of 1/3 x squared dx. Alright, so then we're able to continue through with this, just copying down 1/3 x cubed ln of x, and then we integrate, add 1 to it, make it 3, divide by it, so that'll be negative 1 minus 1/9 x to the third, and then plus our constant. Okay. And so that is the antiderivative of x squared ln of x. Okay. And again, if you tried it the other way, letting u be x, you're going to run into a lot of problems. V would have to be x ln of x minus x. And then when you eventually go to your new integral and multiply that by, derivative of x squared, which is 2x, you're going to have 2x times that stuff. And then that's going to be your new integral to try and work out. Maybe not quite as fun.